Okay, welcome to another Ginger Mathematician video. I'm going to go through everything to do with variation and proportion. So it's about 50 minutes now of this video. I'm going to go through as many exam questions as possible. Valid, of course, for the 0580 course and 0607. Right, let's get started. So question 15, this is a paper 2 question here. So y is proportional to, remember this weird fish symbol, means is proportional to. So that's important to remember for many of these questions here. And we're told some what we call initial conditions. So when x is equal to 4, y is equal to 3, and then find y in terms of x. So first thing we're going to do is take our proportionality statement, so with the weird fish symbol in there, and then we're going to change that into an equation. So the way we do this is we still leave y exactly where it is. We change this to an equals, and where we'd have a 1 at the top here, we change that to a k. Again, if you want more detail on exactly this process, then do check out the video above as well. And at this point, we then just substitute these values in. This helps us work out what k is going to be. So I'm going to make it nice and clear to the examiner. When x is equal to 4, y is equal to 3. Let's pop those in. So wherever I see a y, I'm going to put a 3. The k is what we're trying to find. And then we have the square root of 4. And now this is just a case of tidying up here. So remember the square root of 4 is equal to 2. And then we want the k on its own. So what's the opposite of dividing by 2? Well, we want to times by 2 on both sides. 3 times 2 is equal to 6. And that gives us the value of k that we're looking for. Now, we haven't finished the question at this point. That's really important. We now need to write y in terms of x. That's the actual question. So I'm going to take this equation here, so our basic equation, and now I'm going to replace, let's get the old trusty highlighter out here. I'm going to replace that k with the answer of 6 that we got earlier. So all we're going to do to write the full answer here is y is equal to 6 over root x. And that's really important because many people just stop at this point and go, I've got the constant, it's great, I can move on, but you need to write the answer correctly to make sure you get all 2 marks here. So you can see the mark scheme, and again you pick up a method mark for writing that equation that I did at the start of the question. Okay, on to question 3 here. So y is directly proportional, so that's important, to this kind of like a weird expression here, x plus 1 all cubed. And this is what they're doing with these kind of variation proportion questions. As students are getting better and better at them, they are trying to put a few little twists and turns. Now, we're given some initial conditions, which we'll come back to in a moment. And we need to find the value of y when x is 4. Now, the process I'm going to do here, I'm going to do quite a lot in this video. So even if you're not sure about what I'm doing in this question, you're going to see this process again and again. So the first thing we need to do here is write a proportionality statement. What does that actually mean? Well, we get y is directly proportional to, so proportional to, x plus 1 all cubed. So I've translated that first sentence here. Y is directly proportional to x plus 1 all cubed, and I've written it as a proportionality statement. Now I'm going to do a similar thing to what I did in the previous question. I'm going to turn this into an equation. So I get y is equal to, now this is slightly different to the fraction. We put the k in front of the term here. So we go k x plus 1 all cubed. Again, you're going to see lots of questions like this, so just stick with it and we'll get lots of practice. Now, once we've written our equation, we substitute those values in, just like we did before. So when y is equal to 32, x is equal to 3. And now we just replace the y and x. So y is equal to 32 here. K is what we're looking for. Now x we know, x is equal to 3. Yeah, 3 plus 1 all cubed. And now it's a case of just working out the equation like we did before. So 32 is equal to k. Remember, if there's nothing between the k and the bracket, it means a multiply. So 3 plus 1 here is 4. That means then that 32 is equal to, well, 4 cubed is 4 times 4 times 4, which gives you 64. Again, you can reverse these around as well. And then we want to get the k on its own. So the opposite of timesing by 64 here is dividing by 64 on both sides. This gives us then 32 over 64 is equal to k. If we simplify this down, then that means that k is equal to a half. So again, we haven't finished the question. It's a 3-mark question now, not a 2-mark. So there's going to be a little bit extra that we need to do. So we're going to take our initial equation, just like we did in the previous question. So when I say that, I mean this part here. And we're going to replace that k here with what we've just worked out. So a half. So we're going to write this in. Y equals a half x plus 1 all cubed. And now we need to find the value of y when x is equal to 4. So when x is equal to 4, then that means that y here is equal to 1/2 4 plus 1 all cubed. A lot of calculation work here in these kind of questions. So you get a half times 5 cubed this time. So essentially want a half of 5 cubed, which is 125 divided by 2. I'd be happy with that answer and leaving it like this. You'll see in the mark scheme they actually do divide through by 2, and it's also equal to 64.5. 62.5 even. That's better. For the actual answer you're looking for. So actually cross that out, 62.5. There we are, nice and clear. And they'll, as you see in the mark scheme a bit later on, they put this OE, which means or equivalent. So you can write it as a fraction, you can also write it as a decimal. Now part B is a typical follow-up question to this. So now we want to take this equation that we worked out in part A and find the value of x when y is 13.5. So I'm going to replace the y with 13.5 and leave everything else the same. So we get 13.5 is equal to a half x plus 1 all cubed. And again, this is just a slow process of breaking this down. So let's get rid of the half first of all. So what's the opposite of timesing by a half? Well, actually timesing by 2, because that would cancel. So 13.5 times 2, that's equal to 27. This cancels, that was the whole reason to do that there, giving us x plus 1 all cubed. And when you start getting numbers that are working and nice, this is generally a good sign in a question like this. So what's the opposite of cubing? Well, we want to cube root both sides. And notice the cube root on the left-hand side, the cube root is 27, is a number that we can actually just work out in our head. So something times something times something gives you 27. What is that something? Well, that's going to be 3. So we get 3 is equal to x plus 1. Probably the easiest equation in the world at this point, and I'm sure we can all see at home that x is equal to 2. But this is the paper 4 question, so we're not quite finished. We've still got to do a little bit of rearranging. So what we now need to do is a skill that you see in other questions, particularly my functions video that I went through. So you want to check that out, then please do look at the video above. And we're going to do basically that process there. So we need to find x in terms of y. So we take our equation. So y is equal to a half x plus 1 all cubed. And this basically means we want to write at the end x equals something. That's what the question is actually asking you to do. Now, the way I tend to approach this is first of all flip the equation. So I have the x on the left-hand side where I want it. And then we just work through the process, very similar to what we did in part B. So the opposite of timesing by a half is timesing by 2 on both sides. This cancels. That leaves us then with x plus 1 all cubed is equal to 2y. Now, we try to break this down to get x equals. This cubed is kind of annoying. So what's the opposite of cubing? Well, cube root. So we're going to cube root on both sides. And just take your time, making sure being nice and careful with the algebra. So we're left with x plus 1. Now we get the cube root of 2y. And then lastly, we get, we need to minus 1 from both sides. The opposite of +1 is -1 on both sides, giving us our final answer, because this cancels here, of the cube root of 2y, then -1. And then we just need to write this nice and clearly again for the examiner. One thing to notice here, so if I show you the mark scheme, notice, be very careful with the square root here. It doesn't go over the entire expression, it's just that first part. So notice how I've written this here. I have to be really, really careful to make sure the -1 doesn't sneak in under that square root. So keep that in mind. Okay, you can see the mark scheme. Again, this is a pretty hefty question, it's 8 marks. If it comes up in your paper 4, then it's something that you really want to make sure you get all those 8 marks in as well. Okay, and on we go to our next question. If you found the information so far useful from this video, then please do think about squeezing that like button, because it can spread then to as many people out there as possible. Right, let's continue. So the frequency of a radio wave f is inversely proportional, that's a really important phrase, to the wavelength L meters. A radio station broadcasts a frequency of 93.7, which we'll come back to, and a wavelength of 3.2 meters. Find a formula for f in terms of L, writing any constants to 3 significant figures. So the first thing we're going to look at is the very first thing here I underlined. The frequency is inversely proportional to the wavelength L. What this means, if we use our proportionality statement, is that f is inversely proportional. So we're not just going to write L here, but we're going to write 1 over L. So whenever we're working with inverse proportion, we write the right-hand side as a fraction. And now we have that process of turning this into an equation. Therefore, f is going to equal some constant k, which we put on the top of the fraction, divided by L. And just like you've seen in the previous questions here, we need to work out k by using the information given in the question. Now this comes from a paper 4, so there will be some calculator work to do. So what we'll do now is that when the frequency, so f, is equal to 93.7, then the wavelength L is equal to 3.2. And we're just going to put this into our basic formula. So wherever I see an F, I'm going to put a 93.7. K is what we're looking for. And then we have 3.2. And in order to get the K on its own, we've got this dividing by 3.2, kind of annoying. So what's the opposite of that? Well, we're going to multiply by 3.2 on both sides of the equation. This cancels. So we get equals k here, and now we're going to do 93.7, which I'm just going to do here on my calculator. So 93.7, you can do this at home, of course, and this gives us 299.84. Now we need to write down the final formula. Notice this number, we need to get it to 3 significant figures. That's why I underlined this. So if we think about this as 3 significant figures, this is the first one, second one, and this is the 8's going to round the 9 upwards. So to 3 significant figures, this is just going to be 300. Again, but rounding is very, very important. So I'm now going to just copy this basic equation that we have, but now we know exactly what k is because we worked this out. K is 300, so I'm going to replace that k with 300. So our very final answer, which we want to give to the examiner, is 300 over L. Notice the F equals is already there for us. And very typical on these kind of questions, it gets us to now use that formula for different parts of the question. So chat radio broadcasts with a wavelength of 2.8 meters. Find the frequency of chat radio. So when the wavelength, which is L, so L is equal to 2.8, we just put that into this formula now. So F is equal to 300 over 2.8. Let's go to my calculator. Let's use it on the screen. Okay, so we're going to use it on our screen. So we get 300. We use my CG50 today, divided by 2.8, giving us the answer of 107.14. So let's just write that in, 107.14 dot dot dot. And I generally put this now to 3 significant figures. First significant figure, second, third. The one's not going to round it up, so it's going to stay as 107. And the frequency has no units here, so I'm just going to leave it as 107. Part C, this is very typical. We're going to work backwards here. So all sports radio broadcasts with a frequency of 0.35, find the wavelength. So when F is equal to 0.35, we're going to use this formula. So wherever I see an F, I'm going to put a 0.35. We've got 300 divided by L, and now we just need to do a little bit of equation manipulation. So to get rid of this fraction, because it's kind of annoying, I'm going to multiply by L on both sides, and this gives us 0.35 L, and because this cancels, this gives us 300, and then we want the L on its own. So what's the opposite of timesing by 0.35? We're going to divide by 0.35 on both sides. This cancels, we're left then with L here, and then we get 300 divided by 0.35. Now if you put this into our calculator, like so, so you go 300 divided by 0.35, boom, we get our answer 857.14. 857.14. Again, I still want to do this three significant figures rounding, so we're going to keep this then at 857 meters. Just check the unit here is exactly the same unit as given for the wavelength there. Okay, so you can have a look at the solutions. Notice there are follow-through marks, so this is something to highlight here. So even if you get this formula incorrect, you can still gain the odd follow-through mark if you do the right process with the formula that you have. So if you got K wrong for whatever reason, but you're still doing the right process for B and C, you're still going to pick up a couple of follow-through marks as well. Okay, on to our next question. So question 15 here, similar to one we saw right at the start, so we're getting lots of good practice in here. So first of all, we have our proportionality statement. Y is proportional to 1 over x cubed, or in other words, it's inversely proportional to x cubed. It's another way of expressing it. And the very first thing we want to do here is write this as an equation. So we get y is equal to, so we replace that one with k, leaving everything else the same here. So that's always the first process, writing it as an equation. Now we're going to use this information to work out k. So when x is equal to 2, y is also equal to 2. Putting this into our formula, so we get 2 is equal to, well, k stays the same, and x is also 2, so we put 2 cubed, and it's a little bit of equation solving here. So get 2 equals k over, well, 2 cubed, 2 times 2 times 2, that's equal to 8, and now we want to get the k on its own. So the opposite of dividing by 8 is timesing by 8 on both sides. That then gives us 16 is equal to k. Notice that is not our final answer, because first of all we need to write down our formula. So this is our general formula, and now we know k is 16. We're going to replace this k now with 16 from what we worked out. And so this is kind of like two questions combined in one here. So you get y is equal to 16 over x cubed. And only at this point now we can then answer our question, which is find y when x is equal to 10. So when x is equal to 10, y is equal to 16 over 10 cubed. And 10 times 10 times 10, that's equal to 1,000. Now, one thing I've noticed on these iGCSE papers, they don't really expect you to simplify that often. So you can just leave your answer as 16 over 1,000 to get all 3 marks. This also goes for probability questions. Again, if you haven't checked out my all of probability video, then do check out the video above. But they generally don't expect you to simplify these kinds of answers. You're going to see that in the mark scheme here. If you do simplify it, that's not a problem at all. But notice most of the time you're not going to be penalised a mark for not simplifying your answer at the end, despite maybe what your teachers say at home. Right, let's continue. This is a slightly strange question. This is a paper 4 question, and yeah, just make sure you go through this nice and carefully with me. So first of all, x is proportional to v. Write down an expression for x in terms of v, and our constant here, we've used k so far, but notice we want to use c here for our constant. So x is proportional to v, so x is proportional to v. Now let's change this into an equation. So x is equal to some constant. Now we've used k so far, but we're going to use c here because we're told to use c. And it's just going to be c times v. So that's going to be our first equation there. And we're going to do a very similar process for the next one here. So y is proportional to v squared. And again, we need to write an expression in terms of v again, but our constant this time will be k, which is what we've been using so far. So y is proportional to v squared. So if we change this into an equation, y is equal to some constant k, because we're using k here, and then v squared. So this first question here is just practicing changing your proportionality statement into an equation that we can work with. Kv squared. Now d is equal to x plus y. Notice that refers to what we've done before. And now write down an expression for d in terms of v, c, and k. So we're using our two answers from before. Very typical for a paper 4-star question. We know x is equal to this. We know y is equal to this. And because d is equal to x plus y, we just add these two highlighted things together. So we just add together cv and kv squared, like so. Slightly strange question, and it's going to get a little bit stranger on the next slide as well. So our table here shows two values of v and the corresponding values of d. Now, using your answer to part A3, this is typical on iGCSE papers. If they bold something, really do pay attention to it. So we're using our answer from A part 3. Just a reminder, it's this here. So d is equal to cv plus kv squared. Now, even if I have no idea what to do with that in the slightest, I would still write that down. You might get that mark that you need to get the C to a B or a B to an A. Now we need to show that 125 equals 2c plus 24k. Now, where does that come from? Well, what we're going to do here is we're going to use the very first two values in our table. So wherever I see a v, I'm going to put a 12. Wherever I see a d, I'm going to put a 750. So if we do that, we get 750 is equal to 12v plus k lots of 12 squared. So if we work that out, we get 750 equals 12c, sorry. So I've substituted the v in, so we're left with c. Okay, 12c, there we are, plus 144k. Now you might think this is not the equation that I want, and this is where a little bit of cheating, so to speak, comes in here. And notice I've got a 12c here, and I've got a 2c here. So what do I do to 12 to get to 2? Well, I divide by 6. So a nice sneaky trick here is just to divide everything by here by 6. Noticing I'm using this 12 and 2 to give me an idea of what to divide by. So if you do 750 divided by 6, you get 125. That's a very good sign. 12 divided by 6 is equal to 2, so that's good. And then 144 divided by 6, I'm sincerely hoping that's 24, and it is. So we get 24k for our 1 mark. It seems kind of mean for 1 mark. That seems like quite a lot of work to do. And for the bottom question, which is write down a second equation connecting c and k, we're going to do that in exactly the same way, but now use the 20 and the 2050. So wherever I see a d, I'm going to put a 2050. Wherever I see a v, I'm going to put a 20. So we get 2050 is equal to 20c plus k lots of 20 squared. That then gives us 2050 equal 20c plus 400k. And I'm sure that's fine in terms of the answer. that they're looking for. But I'm going to try and simplify this as well because I'm going to need it later on. Notice 10 goes into all of these. It's the easiest thing to divide by on both sides of the equation. That gives us then 205 is equal to 2c. That's going to be helpful later on, plus 40k. So I'm going to write that in as my answer. Again, a more simplified version of what we've done before. And essentially what this question has got you to do here, it's a nice combination question that they like on paper 4, is actually a set of simultaneous equations. So you've got an equation here, and you've got an equation here, and I assume on the next slide we're going to solve and work out what C and K is, and that's exactly what we're going to do. So let me write these two equations down again. I'm going to write this one here first. 40k is equal to 205, and then the first equation that we worked out. You'll see why I'm writing it in this form in a moment, because as soon as you write it in this form, you can say to yourself, the two c's are the same, and using our normal simultaneous equation procedure, we just minus the equations from each other. Why do we do this? Well, 2c minus 2c gives us 0, which is great, because then we can work out what k is. 40 minus 24, that's equal to 16. And then we've got 205 minus 125, that is equal to 80. And now we can just solve the normal equation here. So the opposite of timesing by 16, we're going to divide by 16 on both sides. This cancels, we get k. Again, you can do this on your calculator, but if you do 80 divided by 16, you're going to get yourself 5. Now, whatever you do at this point, do not celebrate too quickly. We still have C to work out. So we're going to substitute this back into one of the equations. Again, it doesn't matter which one you substitute back into. I'm going to substitute into 1. I think it's going to make my life a bit easier. So I'm going to copy out the first equation. Wherever I see a k, I'm going to put a 5. So we get 2c plus 40 lots of 5 is equal to 205. Notice I've chosen this first equation because 40 times 5 is easier to work out than 24 times 5. 2c, this is just 200, equals 205. And again, standard equation solving here. We want to get the c on its own, so the opposite of adding 200 is minusing 200 on both sides. If this cancels, we're left with 2c. 205 minus 200 is just 5, and then divide by 2 on both sides, getting to our answer here of 2.5, like so. And the last question here is utilizing what we've already looked at. So now we know what C and K are. If we go back, again, this kind of non-linear paper, we need an equation that actually has V inside it. So notice that we've worked out C and K. So that's useful to know. And we need to work out the value of D when V is 40. So if we take this very first equation here, we now know all the information. We now know what D is, we know what V is, we know what V is, we know what C is, and we know what K is. So let me copy that equation across first of all. So probably getting a little bit dizzy me going back and forward. So CV plus KV squared. Now we know when V is 40, we now know C is 2.5 and K is 5. So D is equal to 2.5 times 40 plus 5 times 40 squared. And this is where we get the calculator to do the hard work for us. So let's pop this in. Of course, it will be just a little bit too big to actually see the calculation. There we are. So let's type this in nice and carefully so we get the right answer. So 2.5 times 40. Whilst I'm doing this, you can give the video a like. That would be very, very helpful. Okay, let's pop this in. And we get our answer of 8,100. So So 8,100. And I'm just going to pop that over there as our answer. Alright, so you can have a look at the mark scheme. So gaining all those little 1 mark questions. This was a kind of unusual question. I remember some of my iGCSE students from, I think it's now 4 years ago, it's quite a while ago, they had this question on their very exam and they got utterly confused. So make sure you're not in that situation and you practice this kind of question carefully. These paper 4 questions, they do like connecting more than one topic to try and assess as much as they can from the course. Okay, and on to this next question. So y varies. Now notice they sometimes use this word, so varies inversely. Not inverse proportion, but varies inversely. It means the same thing as the square of x, and we'll talk about that in a moment. And again, typical question, find the value of y when x is 4. So first of all, proportionality statement. Y varies, so we're going to use our fish symbol inversely, so it's going to be something to do with 1 over the square of x, so x squared. Notice how I broke that down. That's the most important skill. Y varies, fish symbol, inversely, it's going to be a fraction with a 1 at the top, square of x, x squared. Once you've got that, then most of the steps are pretty standard. So we then go y is equal to some constant k, replaces that 1 at the top, like we've seen before, over x squared. At this point, we want to use our initial conditions to work out what k is. Let me do that up here. So when y is equal to 32, x is equal to 2. So we pop that in. So 32 is equal to k over 2 squared. That means then that 32 is equal to k over 4. And we're going to pop that in. So then we multiply by 4 on both sides. If we do that, that cancels. We're left with just k. And then we just do 32 times 4, which is equal to 128. So the formula we're going to use from now on in this question is this one here, but we're going to replace the k with 128. So we're going to be using this formula, y equals 128 over x squared, for the remainder of the question. We need to work out the value of y when x is 4. So when x is 4, y is equal to 128 over 4 squared, so 128 over 16. And if you do that on the calculator, I'll just do it here very quickly. That's equal to 8. So our final answer here is just a number, y is equal to 8. Now the last one needs to be a little bit careful with here. So find the value of x when y is equal to 512. So we're going to take that formula in the box. This time we now know that y is 512 and we want to work backwards to work out what x is. So I'm going to copy out that formula. Wherever I see a y, I put 512, like so. And now it's just a little bit of equation solving here. So generally, I like getting rid of those fractions. It's the opposite of dividing by x squared. Well, I'm going to multiply by x squared on both sides. That gives us 512x squared is equal to 128. Now we're going to do kind of same idea as before. So now we're going to divide by 512 on both sides to get that x on its own. It's always that constant battle with equations. Get that x on its own. So we get 128 over 512. Now I assume that simplifies. Yeah, it simplifies down to 1 over 4. And now we want to get the x on its own. So the opposite of squaring, square rooting on both sides, giving us x as our final answer. And this is where we have to be careful, because if we square root a quarter, your calculator is not very clever. It's just going to give you the answer of a half. But just be very careful, because whenever you square root, you always get a plus and a minus, 2 answers. So strictly speaking, the answer should be plus minus a half. I suspect at iGCSE standards for this kind of question, they will just leave it as a half and you'll get all 2 marks. Now, the last question, again, typical to something that we looked at before, find x in terms of y. So we take our formula from before, so y is equal to 128 over x squared, and we want to make it so x equals something. Now, the way I did it before, and it's exactly the same approach here, is I'm going to flip over the equation. Actually, no, I'm not going to flip over the equation this time. I'm going to still multiply by x squared on both sides, get rid of the fraction, so still approach it in the same way. That then gives me yx squared is equal to, well, this cancels, 128. Notice the parallels between what I did in question B and what I'm doing here as well. So now we want to get rid of the y, kind of irritating. So you want to divide by y on both sides. This cancels, then we get x squared is equal to 128 over y. Don't worry if you get to this step straight away, that's also fine too. And now we need to square root both sides, parallel to question B. So we're going to square root both sides. This cancels, we get x equals, don't forget the plus minus, talked about that in the previous question, 128 over y. So to write that in as our final answer. Quite generous, 3 marks for not too much algebra there, but certainly we've got all the working provided to get the answer. Right, you can check your working. So notice they put the plus minus in brackets here, so I suspect they condone not having it, and you'd get all 2 marks, all 3 marks if you didn't have the plus minus there too. Okay, and next question. So this is a paper 2 question, smaller one. Again, works in a very similar way to what we've looked at before. Hopefully you're really getting the pattern of these questions by this point. So y varies inversely as x squared, and we need to translate that into our proportionality statement. So y, it varies, so fish symbol, inversely, so fraction with a 1 on top, x squared, so we just put x squared, and now we translate that into an equation, so y is equal to some constant k over x squared. And now we use these information to work out the k. You probably getting the hang of this by this point, yeah, it's always very, very similar each and every time. So when x is 3, y is 4, that means 4 is equal to k over 3 squared. That means then that 3 squared is 9 at the bottom, and now we want to get k on its own, so we multiply by 9 on both sides. That gives us then 36 is equal to k. And this question wants us just to find y in terms of x, so nothing extra to do here. So in this case, we then just insert 36 where k is, and we get 36 over x squared, like so. Again, very standard paper 2, very short and to the point. You can see the mark scheme there, and 1 mark for writing that equation from somewhere. Okay, and carrying on, so this is a bit more of a meatier question here. So, y varies directly. Notice I'm always underlining this as the square root of x. We haven't seen that yet as a style of question, and given some initial conditions, and we need to find y in terms of x. So again, this is the most important skill right at the start, making sure we write this correctly. Y varies, fish symbol, directly, so no fraction here, as the square root of x. So square root of x. Now we want to translate that into an equation. So we get y equals, don't forget your constant here, so some constant k root x. That is probably the most important part of the entire question. The rest is then some substituting and some equation solving. So when y is equal to 32, x is 16, we pop that in, so we get 32 is equal to k root 16. Now the square root of 16, we should all know, is equal to 4, so we get then 4k, and then we want k on its own. It's the opposite of timesing by 4 is dividing by 4 on both sides. 32 divided by 4, that's equal to 8, and that is equal to k. And don't forget that very last step here. So we take that initial formula, and now we replace the k in that formula with what we just worked out, which is 8 in this case. So our final answer for the 2 marks is equal to 8 root x, like so. And now a very typical question using that formula now for the rest of the question. So find the value of y when x is 4. So when x is equal to 4, y is equal to 8 root 4. That just comes from putting x into this formula here. And that gives us then 8 times 2, and that's equal to 16. Perfect. And now, again, we've seen this question as well before. Find x in terms of y. So we want to take this formula, y equals 8 root x, and write it in a way that we get x equals something. The way I approach this, again, is first of all, flip the equation. So we have the x on the left-hand side, which is always useful. Now, careful the order operations that you do here. We need to divide by 8 first. Remember, it's like reverse BIDMAS, so you do the division first and then the squaring afterwards. So this cancels. We get then root x is equal to y over 8. Generally better to write it as a fraction. And now we're going to square top and bottom here because we want to get rid of the square root. The opposite of square rooting is squaring. This cancels. We get x, and then we get y over 8 squared, which you could also square top and bottom here. That gives you then y squared over 64, which I'm going to pop over here, like so. You can also leave it in brackets too. And then the last question, so this is a nice little twist here. So p varies inversely as q plus 2. It's like, okay, this is slightly different. P is 3 when q is 2. Again, standard kind of question that we've seen already. Find the value of p when q is 4. So let's translate that statement right at the start here into a proportionality statement. So p varies, fish symbol, inversely, fraction with a 1 on top, and q plus 2 then just goes on the bottom. Translate it into an equation. So p is equal to some constant k goes on the numerator over q plus 2. So q plus 2 stays together at the bottom. And then we just want to work out what k is. So when p is 3, q is 2, that means then that 3 is equal to k over, well, q is 2, so 2 plus 2. That gives us then 3 is equal to k over 4. We want to get rid of the fraction, the opposite of dividing by 4, times by 4 on both sides. 4 times 3 is 12, and that gives us our value of k. And again, just like before, we want to substitute it into our general equation over here. Now we know that k is equal to 12. The old highlighter out here. So I'm just going to replace it in here. So p is equal to 12 over q plus 2. And then find the value of p when q is 4. So when q is equal to 4, p is then equal to 12 over 4 plus 2. And that gives us the answer of 12 over 6, also known as 2. And we pop that in like so. Right, you can check all the answers and check everything that I've been through here as well. Again, notice that 3A part 3, all these 3 answers here are acceptable. So you can put any of them down like so. Okay, hope you enjoyed the video. So I'm trying to do more of these all of iGCSE questions. They seem very, very popular. I'll try and get onto transformation, statistics, and some other topics that haven't been done yet. If you want to improve your circle theorems, then check out the video right in front of you, because that goes through circle theorems, lots of detailed questions, and it's a topic a lot of students do struggle with.